Domain and range, but now we have a graph. Cool. I like these better. Remember, the domain is how far you go from left to right. Weird thing about 15 is you are not going from left to right. You have one value. And so when you went across, there's nothing, 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 nothing here. I do have a 2, but then I got nothing again. So my domain literally is just the number 2. Okay, that's it. Okay. How could we have written this else? No, there's no way to write this other than 2. Okay. No, you could have done this, but I've never seen it like that. That's not wrong, but it's weird. It just looks weird to me. 2 is better. 2 is better. All right, but what about the range? Okay, the range is lowest to highest. So the lowest, we go all the way from negative infinity. Let's see. So I guess we'll do, how many are there here? What do we got? We'll do the first 4 in interval, and then we'll do the first 4 in, the last 4 in set notation, okay, because you want to know both. The range is from negative infinity all the way to 5, and we did include 5, okay, and that's it. Negative infinity to 5. Stop. Over here, the domain. Now, don't worry about ovals or circles because we're just going from the widest, we're going from the leftist all the way to the rightest. And it looks like the leftist is right about there, and the rightist is right about there. So it looks like from negative 4 to 4, I have values for x. I've got them underneath here too, but that doesn't matter. I'm going from negative 4 to positive 4. The range is from negative 7, the lowest, to the highest, negative 5. And we do include that. Okay? So don't overcomplicate these guys. Okay? Just treat it like it's about what is the size of the box that this guy can fit in. Okay? What is the size of the box that the function can fit in? Okay, so now this guy, domain, we go from the left, we got all the way to negative 6, and as we move to the right, we got all these values, and it looks like the arrow just tells us, hey, by the way, we're going to shoot off to infinity, and just remember, don't include infinity because you never reach there. Now the range, though, is our lowest value. Our lowest value is right there, and that is at negative 3. We definitely touch negative 3, but if this arrow continues, it is assumed that this guy would keep going to positive infinity. I know you want to put a 1 because that's how high this side went, but this side is going off to positive infinity, so watch out for that. Alright, here things have kind of got switched. This thing looks like it's rotated. The domain, we go all the way from, not this point, but all the way from the left. It's here, okay? And then this guy tells me I'm going all the way to the right to infinity. So at negative 3 is the farthest location I can go to the left. Then I will go all the way to positive infinity, and I never get there. Now the range, okay, the range is we start at this guy, we're going down. So we start from negative infinity, and then we go all the way to the very top, and the very top would be positive 6. And there's definitely a dot there, so we will include it. Now what I want to do is I'm going to switch gears and do the domain and range in set notation. Alright, so the domain here in set is from here to here. So whenever you have an in-between, our domain is all x such that x is in between negative 1 and positive 5. Okay, and close it. Now I'm going to think, do I put a bar or not? The answer is yes. I do put a bar there and there because I do actually reach negative 1 and I do reach positive 5. Okay, now the range from here to here, and I definitely touch those. So I'm going to have all y such that y is in between negative 6 to positive 2. Okay, and again, I can touch both of those. Okay, so this is perfect domain and range for this guy. Alright, domain here. The domain is from here all the way to positive infinity. So we have x such that x is going to be greater than negative 7. Okay, greater than negative 7. The range would be the lowest is negative 6. Okay, now remember the range, we switch to y. We go from negative 6 above. Okay, so we are at y is greater than or equal to negative 6. Okay, now what happens to the infinities? Well, if you are not squeezed in between two numbers, then you only need one variable and you just need to say we're either less than or greater than. If we put the variable over on the left, okay, then we can just basically point to the direction in which the graph is flowing. Okay, so it's very, very important that you do not get these mixed up. We already know this from linear inequalities. You have to remember that this is greater than, this is less than. I don't want you thinking about alligators eating the bigger number. You don't do that. Okay, those days are gone. Okay. All right, 21. You want to think in terms of direction. All right, domain here. Now already I know my domain will have this, right? And it looks like this guy keeps going off, so I'm going way far. So I'm going from negative infinity all the way to this right there, 4. Okay? But watch what's going to happen now. Because I'm going from negative infinity to 4, what I'm saying is I want everything to the left of 4. Okay, I want everything to the left of 4. In set notation, we usually don't put infinity to negative infinity and positive infinities. We will just use one inequality because we're just saying all the way to the left. Okay, then the range would be everything from positive 5 down. So we want the y such that we are y is less than or equal to 5. Okay? So again, if you ever see an arrow here, know that your inequality will only have one inequality. It will not have two like you have here, because this implies a beginning and an end. This guy has a beginning. Both these guys have a beginning, but they have no end. This guy doesn't have a beginning, but he definitely has an end. Okay, he doesn't have a beginning, but he has an end. Okay, last one here. The domain for this guy, we go from negative 3 all the way to positive 1. Okay, that's our domain. Okay, so we want all x such that x is in between negative 3 and positive 1. Okay, so notice though that I do have an in between this. I don't have arrows shooting off to infinities, so that I'm not going to have one inequality. I'm going to have two of them. Now let's just think. Can I include negative 3? No. So I'm not going to have a bar. Can I include positive 1? Absolutely. It looks like I go right up to it and touch it, so I'm going to give him a bar. Okay. Now the range, I definitely have a beginning and end, and so I'm going to have an in between. I'm going to have one right there, put y in the middle. Okay. The lowest is negative 5, and I definitely include them because I can clearly see a point, a filled in circle, and then at the top it is not filled in, so I will not put a bar there, but I'm definitely going all the way to positive 5. Okay? Alright, so that's it for domain and range, set notation, and interval notation.